Oh, good morning, Shrikant. Can you hear me? Good morning, Shrikant. Can you hear me?
Larry, I can hear you.
Okay, fine. Yeah, thanks. Um, because there are so less number of participants here today, I think it would be worth waiting for another few minutes, right?
Sure, yeah. Let's wait for some time.
So, good afternoon, everyone. Welcome to this fourth day of the third week for the summer school training on managing research effectively. And we are having Dr. Shrikant with us. He was helping us with R and he started off with Python yesterday. So he will be taking us on a journey with Python for understanding research better. And yes, it's over to you, Dr. Shrikant. If you would like to start right away, you can. There are almost 7 participants. And if you would like to wait for another 2 minutes, it'll be fine as well. Today is a holiday over here. And that could be one of the reasons like why we have a lesser number of participants. Okay, over
Okay.
to you, Dr. Shrikant.
Yeah, Dr. Larry, let's wait for 2 more minutes and then I'll get started.
Yeah, fine then. I think we can wait for 2 more minutes and we'll get started there.
Yeah.
Meanwhile, sir, I would like to ask a question to Dr. Pawar. May I?
Sure. Yeah.
Yeah,
Yeah,
please,
please.
please.
Yeah, sir. I just would like to know that with R, as you have taught us a few analysis of the microarray. So similarly, suppose if we have to run some molecular phylogeny or some other aspects or some other assays, so in that the coding part, so from where do we have to get the codes? Because this is a part of our language what we have learned, but as I know that coding is a very huge part. So how to learn that, and where are, I mean, what are the sources from which we can get the coding?
Sure. Yeah. So for your specific question with the phylogenetic analyses, uh, there are packages which you need to just uh, search for. Say, for example, I have to do phylogenetic analysis. So I'll just say Google phylogenetic analysis or tree in R. Uh, and then one keyword I usually give is bioconductor. Bioconductor. So there are these different packages which will come up for the tree analyses. And I guess let's look at this package here, Philo Profile. So if I click on this package, then this obviously is an external packages. And so you need to install them as we have done with library Affy. And then you would have a reference manual here, right? So there is a PDF and HTML and R script documents here. So if I click on HTML, it will give you the description of what this package will do. So this will do a visualization and exploration of phylogenetic profiles. So you can read on the introduction on when this package was developed and the paper associated with that, how to install it, how to input the data, and what are the features of this package, right? What things it can do. So this is all the code which you may need, right? So depending upon what exactly is your data frame, do you have a matrix data, you have a data frame, data set, and uh, basically you can use this code to generate your trees or to do the distribution analysis or gene comparison, group comparisons, and so on, right? So this is just one package, but there can be other packages. Say, for example, another one can be phylogenetic trees, right? So this is another package. Again, this is external package, so you need to install it. It's called as RCY3, and it will develop your trees, you develop your networks. Uh, I guess basically that's all it can do. Just a visualization of your tree structure. So the common thing to all of these is this website called bioconductor.org, and most of the analysis packages you would find in this on this website. So it's a kind of a geo data bank, but this is only for the external libraries or packages which people have developed and they have submitted to this platform. So you can search for any of the libraries or packages, and then you will get the reference manual, and then you will also get the sample codes. So try searching this platform, and if you have any specific questions, say with your tree-based analyses or sequencing analyses, then you can definitely reach out to Dr. Larry or me, and we can help you with any of the analyses which we know of. Does
Yeah.
that
Oh,
answer it? Yeah.
yes, yes. Thank you very much.
Okay. I'll just put this link into the chat box so you can make a note of it.
Yeah, Dr. Power, that is very helpful indeed. But then just taking it from Dr. Ankita's point, as in like, what are the other, or whether, let me rephrase this, let me put this way. Are there, or rather, is there a particular database, or sorry, a website, or rather any site wherein we can get to see a list of the things which bioconductor can do, or rather, is it the same page that you're referring to right now?
So Dr. Terry, there should be a list of uh, packages which have been deposited, but it would be a long list. I haven't checked anywhere on the site recently, but there is maybe package. Uh, so
Okay, got it, kind of. So
yes.
yeah, I mean like, yeah, so whatever things are possible via bioconductor, maybe we can get to see the codes and how to install and how to utilize them and how to use them for analysis, etc. Now, why I'm asking is this because there are so many PhD students over here who probably would be very much interested to utilize them. So there's another related question over here coming up at this point, or which is rather stringing up to my mind, is like, which would you prefer better? Rather, which one would you prefer over R, or would you prefer Python for like your this kind of analysis? Whichever that you think of. Let's say network analysis. Let's say gene expression analysis. Which one would you prefer?
Yeah, so I think if it's with the gene expression analysis, with the data visualization, with the uh, there any downstream analysis like pathways or protein-protein interactions, then R is I think is the preferred language for me, at least, because I find all these packages here. So you see this page here, I see there are around 2,230 packages. So I'll find something for for the analysis or a biological data set in on this platform, and this is very specific to R, right? So bioconductor, I don't think it will work with Python. This will only work with R, and any of the biological data, sequencing data, microarray data, chip-seq data, methylation study data, you'll find a package to do the analysis, and you'll also get a manual, a reference manual from the author, so it's easy for us to just implement or replicate. But but say if I'm doing machine learning analysis, right? So anything which is like on the scale of big data, say I have these different images and I want to analyze those images, say immunohistochemistry staining images or radiological images, then in that case, Python is a preferred language. And I can, I was about to show you give more details on how to use Python, but depending upon the data type, for machine learning, for computer vision, I use Python, and then for any of the biological data, I use Bioconductor R.
Fine. Thank you so much, Dr. Shrikant. I guess it's good time to get started. One more thing is just for every day until this Saturday, obviously, because your session is going to get over. Or am I correct that your session is going to get over by this Saturday? And it is Dr. Anand who's going to take over by next week onwards. Is this correct? Or are you going to continue till next week sometime? Or I do not know.
Yeah, Dr. So Saturday, mine is sessions are done, and then Sundays are break, and then Monday from Dr. Anand will take for next 2 weeks. Yeah.
Okay. So until this time, like every day, can you give a very brief, I mean, like brief overview of what was covered in the last day, on the last day, the day before actually, the yesterday. Let's say for today, yesterday, what did you do? I mean, like, sometimes what happens is generally, let's say for me, I was busy with something else and I couldn't concentrate much on your lecture and all, and even didn't get time to actually look through your video. So that's the point I'm saying.
Sure. Yeah. Okay. Yeah. So the last, so I guess last class and all the last sessions were focused on this microarray and analyzing microarray using R. So we did start up with the directly with the analysis, right? So we went into the data itself, CL files, and then how to retrieve your data, how to input that in R, and then how to do the pre-processing using RMA function, and then finally how to do the analysis using a fold change comparison, and you get your upregulated and downregulated genes. Now, we directly started with the analysis, so I didn't got chance to explain the technology itself. So I took time yesterday to explain you the technique itself, right? So how it works. Um, and the microarray is different, right? It's a different technology compared to sequencing. So in microarray, we have a chip, and on that chip, we have probes, while in sequencing, we chop up the sequence. It may be a DNA sequence, RNA sequence, and then we align that to a reference genome, and that based upon the alignment and how many reads or how many chopped pieces align to your reference genome, we get to know the expression of known and unknown genes, right? So The only major difference between a microarray and NGS is microarray is limited with number of probes or number of known genes, while the sequencing it covers the entire genome in the sample. So that's it. So yesterday we just touched upon some differences in and understanding of technology itself. So now we know that the analysis which we did is very specific to microarray. It is not applicable to sequencing. And for sequencing, you have different many packages in bioconductor, right? So if you just type in sequencing in the search box of this website, you'll find so many packages to do the NGS analysis, right? So it starts from read alignment to counting number of contigs or number of reads. Then you can apply so with a package something called as feature count. Then you can find another package called DSIC or HR to do the fold change analysis of those reads in between your treatment and control and so on. But we don't have that time to discuss the NGS uh, program or analysis. But this is my search engine for doing any of these analyses in R. So that was the last session, and as we discussed or we planned that today, tomorrow, and Saturday, we will just look into the basics of Python, right? So we are done with R. So Python, it's completely new language. It's similar, but the syntax itself is quite different than any of the other languages. So in Python, I wish to just touch upon very basics, right? So we are not going to,
Excuse me, Dr. Shrikant.
yeah, sure.
Yeah, good evening, or rather good morning to you. It's evening here. Okay, am I audible? Can you hear me?
Yeah, I
Yes,
can
you're
hear you.
audible. Yeah.
Fine. So I will just post a very brief question to you, as others are also little, trying to clear a little bit of, maybe their, uh, you know, uh, continuing doubts. I have actually showed you the some of the problems, while actually downloading the Affy program, okay, in our, okay, or rather the Affy package as such. So, could you reflect or have some idea why those are happening? If you have, not been able to follow that, or it's absolutely fine. I'm just asking you because, if I could solve that, maybe, later ones, whatever you have shown, I can, maybe with the help of Dr.
Yeah.
Chandrajit, maybe, do these things so that I can catch up till now what it is done. So do you have any idea why those were happening? Because the rest, everything, as I told you, I have checked, okay, all other things, and as Dr. Chandrajit told, I have tried to replicate that with our studio, but again the same things were evident there. It,
Right.
specifically, it was not able to, in that Affy package, it was not able to download few of the, I think, the sub packages or some of the appendages, okay, like that. So do you have any idea, or, you know,
Right.
what's happening?
So as far as I remember, so we tried to share the screen and see the error,
Yeah,
and
yeah,
I believe uh, we tried two different ways to install that Affy package, and then in the next run, it said that iRanges, some other package was not able to
yes,
install.
correct, correct. And
So yeah, so that issue I believe is with the your directory. All right, so because your C drive is a non-writable drive at this point, so you cannot install any of the packages for R, or even if you install Python in that drive, that won't be installed. So you have to change the permissions because you don't have write permissions to that directory. So the
But
issue,
I have actually installed Python, okay, yesterday, and I think I believe it's stored in R, but or rather, I'm sorry, C drive. Though I just have to check, but mostly it is there itself, and it has been installed successfully,
yeah,
Python. So for
yeah.
that,
So
yeah.
sure, sure. But the issue is with the external libraries, right? So when you try you install R or Python, but then from Python or from R, when you try to install external libraries, that is where it causes an issue. So
Mhm.
what I
Yeah,
can
Dr.
suggest,
Srikant, I would like to interrupt here. I mean, like, can we have this discussion at a later part and first continue with our learning a little bit, and then, because otherwise we will lose our patience, I feel like. So it's better
No, no,
that we
that's fine.
start.
That's fine. No,
Yeah,
no,
yeah,
Dr. Chandrajit, I think you're absolutely fine. We can just proceed. I just asked this because it has been,
yeah.
as I have
No, no,
already
I
also
understand that. Yes, yes,
discussed with you, but this
yes, yes.
problem, since I could not, move ahead
No,
of that problem,
we
I
will
could not,
solve this.
yeah,
I already have that in my mind. I
I
definitely will
could
help
not
you.
follow it up actually till then. That's why
We
other
will be
people are
able to.
also asking. So it's fine,
Yeah.
no problem. Dr. Shrikant, sorry for the interruption. You can proceed. We can maybe discuss
yeah,
or try to sort it out later. Okay. Yeah,
Yes,
please
sure,
yes,
go
we
ahead.
will
yeah,
be able to. Don't worry about this. We
Yeah.
will be able. I'm
yeah,
Thank you
sure.
so much. Yeah, please proceed.
okay. All right, so so as I was saying, we in Python, we won't be doing any of the analysis as such, right? So directly in R, we had these five CL files. So data was from some cancer subtype, and we tried to analyze it. But in for Python, we will just look at the functions and syntax and then one very small exercise, right, which is not on any data as such, but just a function to do one thing, right? So, but that is later. So nothing with the data directly, just to get familiar with how to use Python and how it is different from our previous programming language. So once you have installed your Python, then you can open your shell or your compiler. And for me, my version is 3.1 or 3.11.1, and I think yours should be a little higher, 3.11.2 or 4. So anything which is say above 3.11 or 3.10 is fine. Uh, but then if you have an older version and if you're trying to again install any of the external libraries, then that may cause some incompatibility issues. But for now, let's open the uh, shell program. And as in R, we have an option of file and open a new file or a new document, right? So you click on new file, you will have a untitled document or a new document. Right, so this is where you will type in your statements, you can save it, and then you can reopen this document. It will end up with a format of .py. Okay, and this won't be opened in any other programming languages, right? It would be very specific to Python. And you cannot open your R document here, or you cannot open this document in R. Okay. So the first thing, obviously, as we have discussed, we give like a comment. So in comment, I usually use a hashtag, uh, and I call it as say again all the basic things as we did in the R document, which is author, purpose is Python coding, and then the date when it was created, which is just June 29, 23. Then I'll give you um, an intro to syntax, right? So, for example, let's say there you want to print out something, right? So print statements. How are print statements written in Python? Right, so print statements are written with, again, it's a functional programming language, so you'll be using a function. And so you don't have to write how your print statement should be. So someone has written, the developer has written a print statement for you, and the statement starts with the word called as print, P-R-I-N-T, print. And function starts and ends with a bracket, right? So a function, it starts and ends with a bracket. So print, start bracket, end bracket. That's your print statement or a print function in Python. Now, let's say if you want to print, this is summer school 2023, right? So this is what I want to print from a Python shell. So I'll give you a function called print, and then in this function you need to mention what you want to print, right? So I want to print this is summer school 2023. Now this statement here is a string, right? So in order to print a string or characters, you need to mention that to Python that this is a string. So use it as a string, and to let the compiler know that it is a string, you use double quotations, right? So you start with a double quotation and you end with a double quotation. If you forget to give double quotations here, then it will give you an error, right? So for example, let's me run this incorrect statement. So you copy this, you again put it on your compiler in front of this front arrow, and you hit enter, right? So now it will say that it has some syntax error. Perhaps you forget a comma. Okay, so it also gives you some hints on what may be an issue with your error. So the error here is we didn't add the double quotations. So you add the double quotation here, and then you run this print statement on your console. Then it will print, this is summer school 2023. Okay, so that's your simple print statement. It's similar to R, but a few things are different, right? So this is a very basic print statement. This is how you print in Python. So using these statements here, make sure you don't forget your brackets, right? Your open and close brackets, and you don't forget your double quotations if you are passing a string, right? But then if you're passing a variable, right? Say for example, there is a variable which holds a value. Let's see, x is a variable which holds a value 100. Okay, and I want to print again a string saying that value of x is, okay. This is my print statement where it is, I'm just passing a string here, right? In double quotations, I want to say that the value of x is, this is my string, and I want to pass a variable. The variable name is x, and x is holding a value of 100. So if I have to pass a variable in this print statement, you don't need double quotations. So to pass a variable name in a print statement, I just do plus x. That's it. So first I'll run x is equal to 100, which is just holding a value of 100 in a variable called as x. Then I want to do a print statement saying value of x is 100, right? So value of x is plus x. plus is adding and subsequent variable called x input value. So I'll just copy paste it here, and it is giving an error.
Dr. Shrikant,
Yeah.
I think some inaudibility from your side. How was it?
Yeah. Can you hear me?
Yeah, now I can. I am.
Okay. So I have some error here, right? So probably I'm just passing this variable incorrectly here. But okay, so for now, let's see. Let's try to understand how do you pass a print statement and how do you pass a string, right? So you're passing a string. You pass that string in double quotations, and if you want to pass a variable, then you don't need double quotations. Okay, so x is a variable, and there is a way to pass this variable. Okay, so if you want to append a variable in any of these statements, you don't need double quotation. That's all I wanted to explain here. But I'm just making some mistake on passing this variable. I can get back to this later, but just remember that there is a print statement and you need double quotations. And if you want to pass variables in the print statement, you don't need double quotations. So
Yeah,
what are
Dr.
variables?
Shrikant, can I just give a kind of a small feedback here? Can you try writing this value of x and then put a comma and then say x? Don't give that plus.
Okay, let's try
Maybe,
this. Yeah.
yeah,
Yeah,
let's
I think
try
this should
that.
do. Yeah,
Hopefully,
right. This works. Yeah. So yeah, we can give a comma here, which will separate the string and a variable. So value of x is, yeah, thanks, Dr. Larry. So yeah, x works.
yeah,
So you can, so the idea here is in the print statement, if you want to give a string, then you pass in double quotations, and then you can give a comma, and then the variable itself, which is holding any of the int value, right, integer value, you don't pass that with double quotations. And so it will print value of x is space 100, which is what we have stored in x. Okay, that's it. So okay, so we mentioned about what is x, right? So x is 100. So x is called as a variable. Anything which stores some value, it is a variable. It is called as variable in Python. So variables can be, say, we have x, we have y. Y can store a value of, say, 1000. Then we can have z variable. It can hold a string in string value, right? So something like 1000, 1000. Okay, so y is your number or integer. X is 1000 is again a string. Oh, sorry, z is your 1000, again a string. And so let's say a variable called a, and a variable has digits. Let's say 12.88888, right? That's digits. So 1000 is this is an integer value, right? Because it's a whole value, integer value. Z is a string value. Again, a variable is a digit or a float value. right? So these are different types of data types. And again, you can, so I can just copy all of these and then I can run it. So I'll just have to copy one statement, then another statement, and then another statement, right? So I don't have any error. So now Y holds a value of 1000, Z holds a value of string 1000, A holds a value of a float value is 12.88888. And then again, if I have to print all of these statements, then I'll just do print, let's see, A, then print Z, and then print Y. Okay, that's it. So it will print your all the variable values, float value, string value, and your int value. So variables, you don't have to specify, right? As in Java or C++, you have to specify that this is an int value or int variable, right? So if in Java or in C language, you have to specify that, say, int y will hold a value of 1000, right? So this is something which you do in Java, but in any of the object-oriented languages. But you see, it's extremely easy in R or Python. You just have to give any name to your variable, equal sign, and you store your value or input, right? That's it. So, so, so that's your variables. Now you can read more about the different variable types. So these are just 3 variable types, right? But there are other variable types which are not frequently used, but you can read more on types of different variables. Um, and then how can you concatenate variables, how can you separate variables, right? How can you so there are different things which you can do. So this is the basic intro to variables and a very basic print statement. Now, as I mentioned in our last session, right, yesterday, or probably before that, the difference between R and Python, right? A very basic difference is spacing or indentations. So it's something called as indentations. So indentations are spaces. Say, for example, we have this print statement, right? So print, this is summer school 2023. I can again give another statement, another print statement, print value of X is this, right? And if I run this program, right, run the entire code, this will work fine. Okay, this will work fine. This will print this statement and this will print another statement. But say if I have another statement, say if I have given an if statement, right? So so in the next session I will give more explanation on the if statements and while loops, for loops. But for if statements, right? If statement, as the name suggests, if this value is true, then you do something, right? So it has an English definition or an English meaning. So what do you mean by if? If a condition is true, then you do something, right? So for example, I have a statement, let's see, okay, so if 5 number is greater than 2, then print true. Okay, so this is a very basic if statement. If phi is greater than 2, well, obviously that is true, right? The condition is true. 5 is greater than true 2. So if this is so, then you say print true, right? So if I just copy the statement here and run it on my console, it will give you an output true, because 5 is greater than true. But the idea here is, you see in a space here, right? So after if condition, you have a colon, and then once you hit the colon, it won't start from here, right? So you appreciate that if once I hit colon and hit enter, then the next line starts from here. It does not start from here, it is starting from here. So this space here is very sensitive space for Python. If you miss the space, it will give you an error, right? So these are called as indentations, or also called as spaces. And you need to be very careful while giving these spaces, because if any of these are missing in your code anywhere, it will going to give you an error. And this is a very significant difference from any of the other programming languages like R or Ruby, where you just don't care about these spaces, right? If you remember from our microarray analysis, you just don't care about these spaces or gaps or indentations, right? So in the code statement itself. So I just wanted to give you some some explanation on the importance of these spaces in Python. And so if you give a colon, then you hit enter, then it will take you to the correct starting next line, right? The start of next line. But if you miss that, then if you started from say here, or you started from here, or start from here, then it is going to give you a print error, right? Some error type error statement. That's it. So that's your spaces in Python. But probably tomorrow I'll give you more information on what are the if statements, what are the loops, and how do they work in Python. Okay. Do we have questions? I'll just stop for a minute. If you have any questions with these. Yes.
Okay. May not be very much connected to these, but would you like to also throw some light, if not today, maybe tomorrow, as in like the like the operations of the Boolean operators and or not, or because those might be helpful for like the participants, and like they would like to use them, and
Yeah,
also
clearly. Yeah.
mathematics, a little bit of mathematics in here as to how they can do mathematical calculation, any calculation for that matter. Sometimes that can also be helpful.
Yeah, clearly. Yeah, I have that in my to-do list here. Some booleans, and how do you pass the operators. Um, so probably, yeah. So maybe tomorrow I can go more on these uh, descriptions. Yeah, I'll go through this tomorrow.
Right. So what we are planning, rather we can plan this way that the moment you come in, we would just wait for 2 minutes, 2 to 3 minutes maximum, and then we'll get started without any other further questions and or any other thing, so that you can cover up as much as possible, obviously giving some backdrop of whatever you covered today, and so that you can recapitulate or rather put the listeners into your shoes, kind of like thing, and then get started with them, so that you can cover quite a lot like tomorrow, I think, because the days are now getting, it's just we have 2 days left. I'm just thinking like how much will you be able to cover, but anyways, you can do that, I
Yeah.
guess.
Yeah, definitely. Yeah, let's do that. So tomorrow I'll go through the Boolean values and operators, and then after that we will go over the loops.
Right.
Um, and one last thing before we end the session is, okay, so now you're doing all these Python statements, right? You're running all these Python statements on a compiler which is on your computer, right? Because you downloaded a Python program software on your computer. So your computer is running these statements and it is generating an output, right? So it's everything is local. But uh, if you're working with any of the big data machine learning applications, then your computer uh, may not have that much capacity in terms of memory or processing units, right? So in that case, this is a limitation. You cannot run your code on your local computer. So people are using these free resources, like say Google Colab or AWS. So I just wanted to give you a brief intro on what is this Google Colab. So if you just Google Colab or Google Colab, COLAB, then you can there would be link collab.research.google.com, right? So and obviously if you have a Gmail, you can use that Gmail to sign in to your Colab account. It's free, right? So once you sign in, this would be your home page. Welcome to Collab. You will have you can get information on some videos on how to do the analysis in Collab and the features which they provide. So this is a free to certain limit. Okay, so you can run like 3 or 4 Collab Python notebooks at one time. But there is obviously a limitation to these free resources. So on this tab here, you will have the options to create a new notebooks. So these are same as Python notebook, right? So these are same as our Python documents. So let me just show you one example of creating a new notebook. Right, so once I hit create a new notebook, it will open this untitled IPYNB file. Now this is similar to py file. So from our Python code, this is our py file, right? I haven't saved it, but if you save it, it will be .py format file. For this Colab, you will have a file IPYNB file, which is Python file, but it's an interactive file because it is coming from Google Colab. Now this is the same format or similar format to your local document, right? So here you type in your code. So let's type in our code just a print statement, a simple print statement. Print, this is summer school 2023. And you can run this using this icon. So you play icon here. So you click on play icon, then it will run and it will give you an output. This is your output. This is summer school 2023, your print statement output. So the idea is this Python is running on Google Cloud. Okay, so the data, if you store, it will be stored on a cloud. You can run it. You can run it like uh, um, so you can keep things running on the cloud. So and also you can collaborate, right? Collab meaning you can people can collaborate on your code like on real time, right? So you can write your code and someone can also write their code and they can run it. So and the session can keep on running because it's on cloud, right? And then most importantly, you can choose your resources. Okay, so you can choose your resources, how much RAM you want, how much disk space do you need? Do you want to use a CPU or do you want to use a GPU? How many GPUs do you want to use? So all of these resources are provided by Google. Okay, free. So if you have like a big data and you cannot store it on your computer, you need GPU, you need more processing units to run your code, then you can use Colab and you can manage your resources, manage your sessions, um, and this is a very useful resource if you want to do any of the machine learning training. And then you can also download your notebook You can save it on your Google Drive. Um, you can print it. You can upload previous notebooks. Um, so there are many things which you can do, which you cannot do locally in your Python program. Okay, so that's all. So you can explore more on this, and if you are comfortable using this, because people are mostly using Google Colab or similar to Colab is there is something called as instance, right? AWS instances, Amazon Web Services instance, which works similar, but it's little different than Collabs. I feel it's the most easiest and most friendly version of running Python on your cloud. All right, so that's all I have. You can look into it if you have questions. I would be very happy to discuss more on Collab, but I would suggest you to switch to Collab, right? So these things we run it locally. So you can try to just run them on Collab and get familiar and use Collab instead of Python locally. Okay, all right. So that's all I have for today. Any questions?
Yeah, the floor is now open for questions from the participants. Anyone? Dr. Devashish and Dr. Ankita, any other participants?
No, I don't think I have any questions now. I think that was a really nice resource, online cloud platform based what Dr. Shrikant showed. I think maybe we can do more and explore to get more hands-on, but I think this is really nice. We can do some practices maybe in the 2 days remaining. Thank you, Dr. Shrikant. Yeah.
Okay, welcome.
Okay, so we are still expecting, but if there be nothing, just one or two words from me, Dr. Shrikant. Apart from the Google Colab, why don't you show them also Jupyter Notebook so that that becomes much easy from Anaconda. Don't you think that that would be a good one to give them some backdrop, like maybe tomorrow, obviously not now, just few minutes of like how to get into Jupyter, and also because like whatever you can do them in Jupyter, you can quickly transfer to Google Colab, and vice versa. Whatever you do on Google Colab, you can take them to Jupyter because of the .ipynb extension, whatever that you know that. So yeah, and like also what you can do is I'm not sure how many days now. It's just only 2 more days. If you would have given some small homework type of thing, like small exercises kind of thing, that would have been helpful so that people would have tried those things on their own at home, and then they could have quickly asked you one or two things in case if they would have fumbled. So that thing would have been a little bit more helpful, maybe. But yeah, I know the time is short now. That's just a kind of small suggestion from my side. Yeah.
Sure, Aklari. Yeah, I can definitely take on your suggestions. I think you're great advice. First is the Jupyter Notebook. We can discuss that tomorrow. Again, I'll just give you a brief overview of what is the notebook and
Yes.
similar to how it works, right? Uh, and then also an assignment. Um, yeah, I'll think on what assignment can be done on the
Give them very small types, brief types
yeah,
actually, so that
yeah.
encompassing whatever knowledge that you are saying or rather giving, they can utilize them to carry on or conduct them on their own, and then come back to you and discuss that.
Yeah,
Something like
Raghav. Yeah, yeah. Yeah, I will think on that, and probably tomorrow I'll give us very brief work just to practice. Yes.
okay. So if there be no other questions, I would thank.
I just have a quick update
Okay.
to Dr. Shrikant. I think this, the Python again, the program is running a little different in Windows compared to your MacBook. In it, actually, there is no different file as I can see. And what I actually downloaded and at least whatever I'm getting, there is not a different shell, like you can, as you are showing, idle shell or compiler. It's a single platform. I mean, you can do all the things there itself. So there is no need to copy, as showing your MacBook, copy and again paste it and run it. You can just directly run it and show it. As such, there is no option to open a new, new file and then work on it and paste it back. Actually, in Windows, I don't know how it is others, but for me, it is like that.
Yeah, Dr. Devashish, but you need to save the run, right? So whatever you run on your on the shell or a compiler, that you need to save somewhere. You need to save it in a like a document, a Python document, because if you close this shell, this runtime, it will be erased. So make sure you have something which is like a document from that program where you can copy and paste it and then save this for the next session.
Yeah, I think one or two people can quickly clarify this, whether they're having some kind those options or not. I mean, I can share my screen and show you what exactly I'm getting.
I think Dr. Lahiri is using Windows. So maybe Dr. Lahiri, do you see these two documents or just one shell file window?
Generally, I use Jupyter and Google Colab both, but I don't use the standalone type that you're saying. So preferably, I use Jupyter because that gives me a lot of freedom. Colab is very nice. I earlier used to use Colab, but these days I've shifted back to my Jupyter. So about exactly what Dr. Devashish is just now right now said, I don't have much idea. I'll just look through this and I'll also try to get back tomorrow. I really don't have much idea about exactly what he is trying to say.
Okay.
Maybe we can discuss this quick tomorrow, or if any other participants like Dr. Ankita or Daksha or Devika Panikar or Jahal, Shruti, Unnati, are other students, other participants, other PhD students over here. If they can say something, if they have done something, they might like to put some word over here. Is there anyone? Devika Panikar?
Yeah, actually, one or two quick comments from others would have really clarified this. Whether again this is very thing only for my system, or is it everybody is having the same kind of platform? Means I can show my screen if
Okay.
Yeah, I
Yeah.
can have a look actually.
just a second. I'm maybe I'll just show my screen and
Just now, Dr. Devashish called. He's having some kind of issues, and it seems like he cannot connect. Shrikant, I think we can call off this meeting over here itself. And if there be any other doubts or clarification needed, sorry, we can just discuss them tomorrow. Will that be fine?
Yeah, Dr. Yeah, okay. Let's discuss this tomorrow. Yes.
Right. So thanks everyone. Thanks for joining us today, and let's meet tomorrow once again for continuing. Thanks
All
everyone.
right.
Yeah. Have a
Okay.
nice evening. Thank you,
Yeah.
Dr. Shrikant. Have a nice day.
Yeah, Dr. Take care. Bye. Bye.
Bye bye.